Now, when we're drawing organic molecules, it is not uncommon to have, this long chain of, or even multiple chains of carbon atoms all linked together, in some way like that. And, you might have some other types of atoms in there as well. And then each carbon has 4 bonds, and there's always a lot of hydrogen around. Okay, so if you write this out, all right, and you include all those hydrogen atoms, all right, you realize very soon that there's a lot of atoms in these molecules. And when you're writing this out, for just this one example, I mean, it takes a good little while to write out all of those atoms. Okay, so that gives us a good incentive to simplify this. And also, it's kind of messy, lots of letters everywhere, and it's hard to follow it. And so we have a simple format that we will use, and I use it quite extensively, because it's much simpler. And the only atoms that we actually write their letters are anything besides carbon and hydrogen. Since there's so much carbon and hydrogen, we don't write them, we imply them. Okay, so the way we do that is we take this carbon skeleton and we draw it, okay, in kind of a zigzag arrangement, where each the ends of the line and each point reference a carbon atom. So instead of drawing the C, I just know there's a carbon atom there. There's a carbon atom at that tip, at that point, at that point. So what I've shown here are 5 carbon atoms in a chain. So that would be like 1, 2, 3, 4, 5. Let's go ahead and put in a couple more. So there's my 7 carbons in that row. Then on the 3rd carbon, I have one coming up. And now I'm going to go ahead and just draw it down. So it doesn't matter as long as it's attached to that. These molecules are always wiggling around anyway. So get used to seeing them from different angles. All right. And then on the next carbon over, we have 2 more carbons attached in a chain. So it might look something like this. Okay. And then we have 1 carbon, and then the next carbon there, it has 2 more CH3 groups attached as well. So what I've drawn here is just the carbon skeleton. All right. Now, to further simplify this, in addition to not showing the C's, I also don't show any hydrogen. Okay. All of those hydrogen, those 3 hydrogen, I know there's got to be 3 hydrogen there, because I'm showing my bond to carbon. I have 1 bond to carbon and to this carbon, and every carbon atom has to have 4 bonds. All right. So if I have 4 bonds to this carbon atom, one of them is to this neighboring atom, that leaves me with 3 bonds to hydrogen. Right. So I know that there are 3 hydrogen atoms there. I'm not going to write them in for simplicity. Right. So here, how many hydrogen atoms would there be? I have 2 bonds to carbon shown, and then that leaves me with 2 more to fill up the 4 bonds for carbon. All right. This carbon atom, I'm showing 3 bonds, which leaves me with 1 more. So there's only 1 hydrogen attached to that carbon. Only 1 hydrogen attached because I'm showing 3. 2 hydrogens attached, 3 hydrogens attached. Showing 2 bonds there, only showing 1 bond for this carbon. Alright, so here I have 2 hydrogens attached because I'm showing 2 bonds. Here I don't have any hydrogens because I'm showing all 4 bonds are connected to different carbon atoms. But each of these carbon atoms on the end, I'm only showing 1 bond, so they each have 3 hydrogen atoms attached. Right? So in that way we can imply the hydrogen and we don't have to write it out. Okay? But any other element, like the oxygen, we have to write that one in, and that's on my second carbon. So I would put that in, there's my bond to the oxygen, and then quite often when hydrogen is attached to another element, we don't imply those, but we don't necessarily write it with the line in between. We just write it like that. Okay? But this line here is the bond to the oxygen. So it's not somehow implying that there's a carbon at the end of that line. No, the oxygen is at the end of that line, connecting this carbon to the oxygen. Right? And so the only time we write hydrogen is when it's connected to some other element besides carbon. So taking all of this, we can simplify it right down to that, and then you can see very clearly the carbon skeleton or the backbone for that compound. Okay, so this is a very common technique for drawing organic molecules. You'll see it quite often, and it's good to understand what it means and how to interpret those kinds of formulas.